All right, we have problem 15. Which of the following is equivalent to the square root of 32 times the fifth root of 64? So first of all, anytime we have a square, so let's say we have, or the square root of x, that actually equals this equation. So we have the second root of x, right? So then just the same, we can denote like the fifth root of x. Just like they're doing in this problem, the fifth root of x, okay? And that's going to mean that there's some number that x equals where x equals a to the fifth power. Because then when we plug that into our equation, they're gonna cancel out. We have the fifth power of like a to the fifth, and those would cancel to equal a. So it'd be some number, right? Some real number, right? So one distinction we can make right off the bat is all of the answers include a 2 in them to some power. So let's look at powers of 2, right? So 2 to the first power equals 2, 2 to the second power equals 4, because 2 squared equals 4. 2 to the third power is just 4 times 2, which equals 8. We can start to see a pattern, so let's do 2 to the fourth power, so this times 2 again equals 16. So every time they're just doubling, so 2 to the fifth is 32, 2 to the sixth is 64, 2 to the seventh is 128, and so on and so forth. But since our answers in terms of this, we also see in the question 32 is 2 to the fifth power. We see 64 is 2 to the sixth power. So let's rewrite our equation. Instead of the square root of 32 times the square root, or the fifth root, sorry, of 64, that's going to equal the square root of 2 to the fifth power. I'll sharpen my pencil so you can get a super sharp point there on that 5 so you can see better. To the fifth power, I'll watch better, times the fifth root of 2 to the sixth power. Okay, then we also know our fraction rule, where if we have x like squared and it's the cubic root, that's going to equal x to the 2 over 3 power, or the 2/3 power, okay? So then this x1 of x becomes the numerator. The number or nth root that we're taking of x squared becomes the denominator. So we can do the same thing here. Remember, for our square roots, there's an invisible 2 that goes here. So then this is going to equal 2 to the 5 over 2, ith power, times 2 to the 6 over 5, ith power, okay? Now we have the same base, so we can apply another law, okay? Here's another one, which says like if x squared is multiplied by x fourth to the fourth power, because they have the same base, that's going to equal whatever their sum is, the sum of the exponents. So that's going to equal x to the 2 plus 4, which equals x to the sixth power. Note that they're not multiplied together, they're added together. Like, for example, the square root of x times the square root of x equals x to the 1/2 times x to the 1/2, which makes sense that would equal 1, right? Or would equal x, sorry. Because the square root of x times the square root of x equals also the square root of x squared. We know those cancel to equal x, right? So again, when we have 2 of the same bases, so like x's or 2's, for example, and they're multiplied together by some, and there's some exponents, we can add those exponents together. So we have 2 to the 5/2 plus 6/5. All right, but can we add those? No, we need a common denominator, right? So common denominator for 5/2 and 6/5, we can multiply by 5 over 5 and multiply by 2 over 2, because multiplying by those, just multiplying both of them by 1. 5 times 5 is 25. 5 times 2 is 10. So 5/2 equals 25 over 10. 2 times 6 is 12. and 5 times 12 is 10. Again, we're just doing this to find a common denominator, which we have now. We have 10 as our common denominator. So 6/5 equals 12 over 10. 5/2 equals 25 over 10, which again makes sense. We can divide the whole thing by 5 again to get this original one. We can divide this whole thing by 2 to get the original fraction. And now we can add them. Because when we're adding fractions, if they have the same denominator, we can just add the numerators and carry over our denominator. So we have 2. I'm gonna write it really small so we can see our fractions. And then 5/2 equals 25 over 10. 25 over 10. And that's gonna be plus 12 over 10. Which is going to equal 2 to the 25 plus 12, which is 37 all over 10. Okay, now we're getting somewhere. So then just like we can put these together, we can also break them apart. All right, so then 2 to the first power is what we're looking to take out. This is gonna be a mixed number, okay? So we can split this into like 2 to the 10 over 10 plus 10 over 10 plus 10 over 10 plus 7 over 10. 10, 20, 30, 7, right? Okay. Then we can do exactly what we did up here in reverse to split into something more workable. It's a nice little trick we like to use because this is going to equal 2 to the first power. 2 to the 10 over 10 is the same as 2 to the first power. So we have 2 to the 10 over 10 times over 10 times 2 to the 10 over 10 times 2 to the 10 over 10 times 2 to the 7 over 10. Again, we're just using this property we used up here to put them together by adding them. Since we're adding them, we can now take them apart by multiplying them, okay? Same property in reverse. So then 2 to the 10 over 10 equals 2 to the 1th power, or to the first power, sorry, times 2 to the first power, times 2 to the first power, times 2 to the 7 over 10th power. And 2 to the first power is just 2 times 2 times 2. We can put the little together. Times 2 to the 7 over 10th power. 2 times 2 is 4, times 2 is 8, which is 2 to the 3rd power, which is 8. So we have 8 times 2 to the 7 over 10. If you see a shadow, it is my cat Leo. He's very, very curious about what I'm doing and the math I'm doing. He's pretty good at math too. You'll see if he comes on screen. That's his shadow. So then 2 to the 7 over 10 is going to be carried down because we haven't done anything with that yet. And then just like before, when we took our square roots here and our root functions, we made them a fraction. We can take our fraction and make it a root. Carry 8 down. So you can do that by leaving the 2 alone. The 7 becomes our exponent, and the denominator, the 10, goes in front of the radical sign. And now we're almost done. We can just write it together because all those answers are together. We can write our multiplication like this. 10 radical 2 to the 7th power. And we're done. And we can see that that answer is going to be D. The hardest part of this is keeping all your laws straight and knowing what you can and cannot do with radicals. Even I made a mistake. If you look at, you're seeing pencil marks up here. It's because the first time I did it, I missed one of the rules and I didn't follow it appropriately. So I had to restart the problem to make sure I was doing it correctly. I made a mistake, so I restarted. But you can see that the answer here is going to be 8 times the 10th root of 2 to the 7th power, which is D.